Hey, Nevaeh, this is Mr. H. Hey, I'm going to do a few more questions, and then I'm going to post these to your playlist. All right, this is question number 34 on page 2. It's a word problem. They give us this formula. It's called it's the amount of time it takes for a pendulum to swing. It's called a Foucault pendulum. And basically what we have here is we have T equals 2 pi times the square root of L divided by G. L is the length of the pendulum in meters, and G is the constant 9.8 meters per second. That's the acceleration due to gravity. And so what they're saying is if the pendulum has a length of 67 meters, it says determine to the nearest tenth of a second the time it takes. So we're basically going to do this. What we're going to do is we're going to use this formula. It's 2 pi square root of L over G. And what we're going to do is we're going to, once we get all of this information in, we're going to use nsolve to solve it. And then the very last thing that we're going to do, I'm going to change the color, is since we're going to be solving for T, that's what we're going to do. So what we're going to do is we're going to store 9.81 into G. We're going to store 67 meters into L. And then we're going to calculate using nstore T. Let me get rid of that. Oh, why does it keep doing that? Calculate T. I don't know why it's doing that, but anyway. All right, so now what I'm going to do is I am going to go to the calculator, and I'm going to do that. So over here, what I have, I'm going to store 9.81 into G. That's done. Then I'm going to store 67 meters into L. And then I am just going to use nsolve. So it's menu, algebra, and then the very first one. So then all we're going to do is we're just going to type in that formula, the pendulum formula they gave us. So it's going to be T equals 2 pi 2. Here's the pi symbol. And then we have the square root of L over G. And then I'm going to get outside of this, and then the very last thing I do is do comma, and then the variable that I'm solving for. So I'm solving for T, press enter, and it says it's going to take 16.42 seconds. Now they want us to round that to the nearest tenth. So the 4 is in the tenths place. We look to the right. It's 4 below, so we just let it go. So this answer is going to be 16.4. So T equals 16.4 seconds. Now, the second part of this, it says another Foucault pendulum at the United Nations building takes 9.6 seconds to complete one swing. Determine to the nearest tenth of a meter the length of the pendulum. So basically what we're doing now is we're going to use the same formula, but now they've told us the amount of time it takes, so we know what T is. So we're going to take T and we're going to store 9.6. G is already done. We've already done that. And now what we're going to do is we're going to solve for L. So we're going to use nsolve again, but in this case, it's going to be, let me erase this. Instead of solving for T, we're going to be solving for L. So let's go, calculator. let's store the numbers. So the time is 9.6. So it's 9.6. We're going to store that into T. And then watch what I do. I'm going to go up here. I'm going to copy this, and I'm just going to replace the T with an L, and then I press enter. And it says 22.9. We're supposed to round it to the nearest tenth of a meter, so it's going to be 22.9. So the length of the pendulum was 22.9 meters. I'm not sure why it keeps doing that. Let me see if I write it down here. 22.9 meters. That's our answer. All right. Now, the reason that I gave you this problem, Nevaeh, is that I wanted you to see whenever they give you a formula with a bunch of variables, and then they have to give you some of the information to put into those variables, you should use insolve. I know I have a rule that says when you see an equal sign, you should graph it. But the exception to that rule is when we have a bunch of variables, because you don't want to be graphing all that stuff. I mean, you still can do it, but I think insolve is better. All right, so now I'm going to stop this and post it.